So problem C is another problem with missing angles. And here we're given that we're to find angle x, the measures of x and y in these two angles. We can see again that x and y here appear to be linear pairs. That might help us. In addition, we're also given an exterior angle 78 degrees. And then we're given this angle here that's 35 degrees. Is this 35 degrees an exterior angle or not? It's not. Okay, if you thought it might be, I could understand how you might be fooled into thinking that, but notice the difference between an exterior angle and one that is not an exterior angle. 78 degree, this angle, is formed by a side of the triangle, this sort of right slanted side, along with the extension of an adjacent side. But the angle 35 is formed by extensions of two of the sides. Okay, that extension and this extension. It doesn't have one of the sides of the triangle as one of its sides. Okay, so 78 does have this side of the triangle, but 35 only has two extensions as its sides. So 35 is not an exterior angle. So you will get tricky problems like this frequently. You have to be able to identify the exterior angle. Where would the exterior angle be here? This is one exterior angle over here, for example, where I just drew that curve. That's an exterior angle. It has this bottom part of the triangle and this extended side as some of its sides. Can you locate some of the other exterior angles in this triangle? You should try to. Okay. Well, we still have to solve for x and y, but it may not be the easiest to use the exterior angle theorem here. So what would be a way to do this? There are actually a bunch of ways we can use. We can use the exterior angle theorem, so I'm not going to rule that out. In fact, let's go ahead and do it that way first. Let's go ahead and use the exterior angle theorem first, and then we'll use a different way. Can you see how we could use the exterior angle theorem, even though 35 degrees is not an exterior angle? Well, we pointed out that this was an exterior angle over here, and this and 35 are a linear pair. So we actually do know and can easily figure out the degree measure of this exterior angle. It would be 180 minus 35 degrees, which would give us 145. Okay, so this exterior angle is 145 degrees. Now we have the measures of two exterior angles, 78, 145, and which of these two is exterior angle? Is it x or y? It's y. Okay, so y is our third exterior angle. We know that the sum of exterior angles has got to equal to 360, so let's go ahead and do this math problem. 145 plus 78 plus angle y has got to equal to 360. So, do it on my calculator here, 145 plus 78 is 223. So we've got 223 plus y is equal to 360. And now if I take away 223 from both sides, I get y is equal to 137 degrees. Or 137, and y is 137 degrees. Okay, so you can figure out y that way. And if we know that y is 137 degrees, since x and y are linear pairs, we know that 137 plus x has got to equal to 180 degrees, or that x is equal to 43 degrees. Okay, so we can figure out that way x and y. But we could have also used the sum of the angles of a triangle is equal to 180 degrees. And in fact, I want to do that in order to double check my work. So let me go ahead and figure out what the angles of this triangle should be, and then figure out whether we've done a good job or not. So this angle here in the lower left corner is vertical to 35 degrees, so we know that's a 35-degree angle of the triangle. We know that the top angle of the triangle is a linear pair with 78 degrees. So that would make the top one what? What would be 180 minus 78? That would be 102 degrees. Okay? And then finally, we said x is 43. We're claiming x is 43. Well, let's go ahead. Let's add these three together, and let's see, do they equal to 180? 102 degrees plus 35 degrees plus 43 degrees equals, I'm going to take my calculator out again, double check that, 102 plus 35 plus 43 is equal to 180. Okay, so everything checks. The answers are correct.